Hi there, and welcome back to another episode at Station Road. Now, in today's episode, we're revisiting this footbridge, of course, which I did a couple of episodes ago, where I assembled a hybrid footbridge, which is what this is, which is a combination of laser cut components and also 3D printed components. So in the episode where I'd prepared the design and did the assembly of this footbridge, I mentioned that I was also going to look at doing a fully 3D printed version of the footbridge, because one of the issues, of course, that I had with this particular model was getting the 3D printed posts or columns to fix suitably or well enough to the laser cut components. So it became a bit of an issue, and at various points they broke away and wasn't ideal. Now, there are a number of comments, of course, about that, and of course there was ways of being able to print probably more of the column structure and the lower structure, so there was something more for, in terms of the surface area, for the glue to attach to the laser cut components. But in the end, I sort of thought I really did want to actually try a fully 3D printed version. So in this episode, we're going to take a dive into that, and I think really at the end of the day, it's actually looking at the design process that I use for this, which was essentially geared towards laser cutting, but how I use that design to generate 3D model components within TinkerCad. So firstly, I take a look at TinkerCad and how I use that to generate the 3D models and be able to bring them into Bambu Lab, which is the slicing software for the Bambu A1 mini printer. And then after all the individual 3D printed elements have been produced on the printer, which essentially are really like kit set pieces, I go through the process of assembling the 3D printed bridge into one structure. So first things first, let's just jump into a little bit of 3D modeling. So we're going to jump on the computer, and the first thing we're going to take a look at, of course, is TinkerCad. Now, this is not going to be a full in-depth tutorial in how to use TinkerCad. It's actually a pretty easy bit of software to use, so it's more looking at what I've done with some of the models and looking at some of the shapes that are available in TinkerCad and how you can manipulate them to create more complex shapes. So as we can see, what we've got on the screen here is we've got some of these posts. Now, these were the posts that I put together for the first prototype course, which is that sort of hybrid prototype for the footbridge, which is a combination of 3D printing and also laser cutting. Now, as you can see here, and this is one of the first processes I went through to get around how to print these without the need of support. So I did do a print of one of these posts, like a full post, in a vertical format on the printer, and of course it made complete mincemeat of it and went all over the place. It kind of ended up looking like something out of a Dr. Seuss book. So the first thing I had to look at is, well, how do I get around that? It was clearly better to be able to print objects on the hotbed in a horizontal or flat format rather than sort of narrow vertical objects. So of course the first thing I thought of, well, let's just split the posts in half and then of course glue them together afterwards. Now, this obviously is not in halves, it's roughly 2/3, 1/3 split, and this is based on the second prototype, the fully 3D printed footbridge. So there's two different processes I actually have kind of adopted when it comes to assembling these models, these 3D models, and one component involves using Illustrator, or you could actually use Inkscape because that's a free vector-based software program. And the other is actually using some of the shapes here that we can see on the right hand side. So when it comes to doing these components, sort of particularly when it comes to doing round components or curved components and things like that, it was easier for me to do that here directly within Inkscape. So these shapes here, so if I actually select one of these and I actually begin to break it apart, so we'll do a little bit of reverse engineering here. Now up here we've got some very basic sort of functions up here. So these two here are the key components. So we've got group and ungroup, and they basically kind of like weld different components together to make it into a full object. So at the moment this piece here is actually made up of quite a number of items out of here. So for example, this here, this sort of knobbly curved piece here is actually one of these. It's basically a donut. And then we've also got just cylinders, and of course we've got basic cylinders in here somewhere. The orange one there's a cylinder. And then we've got some other unusual shapes. For example, at the bottom of this block section here, and you can see how we've got these sort of beveled corners on here. That is one of these down here, is the dice. So if I select this and actually begin to ungroup it, what we can actually see is it's starting to pull the items apart. Now we can actually see the whole shape, and of course what I've done is just shoved in a rectangle which is on whole, and that then splits the item in half. Now if we move that out of the way, and then we've got our entire shape in here, and then if we ungroup that again, you can now start to see we've got the shapes in here. So there's your donut in there. So this shape here, this is an unusual shape, I think. Let's just pull this apart. So there is a shape in here that does this, and it might be in one of the other menus, because as you can see we've got basic shapes, we've got design starters, there's all sorts of stuff in here that you can sort of work for, even electronics. There's quite a few sort of pre-designed shapes in here, so it's a case of sort of working out, ooh, that shape will work for me. If we ungroup this shape, what have we got? We've got another donut, and if we ungroup this shape, we've got basically a ring which is set up as a hole. So anything that's sort of transparent, that will cut away. And then we've got this shape here, which is the super ellipse shape, and that is a native shape, and as you can see it's got that sort of concave point on it. So that's sort of, it's very basic. I'm not going to go into, because we spend hours actually looking into this and actually sort of trying to, you know, understand different parts. You see we've got our block down here, that's just a basic block. This is our dice. If we ungroup that and take away the hole or the cut section, there's our dice. So you can begin to see how these columns were just built up from shapes within TinkerCAD, and it works quite well, because within here, if I select, you know, if I hover over these nodes, you can see that that's 1 millimeter in depth, and if I hover over this one in here, we can see it's 3 millimeters in width, and of course 3 millimeters in height. So you can actually do it's reasonably precise in terms of being able to set the dimensions of these items. For example, this cylinder here is 27.8 millimeters, so you can go down to 2 decimal points, which is pretty good. That's not too bad. So there is our, that's a sort of basic rundown of posts for doing these items. These were the only components that I did actually generate entirely within TinkerCAD. Now if we switch over to Illustrator, and this is my sort of design file of the, looking at it more in a two-dimensional format. So these are all the different components for making up this footbridge. So you can see here there's it's a bit of a mess. I can understand it, but it's good enough for my situation. I could really actually kind of maybe tidy this up a bit. But as you can see, we've got sort of like different layers or different levels of our components here. So what I was going to do is, if I look at, for example, an end piece here. Now if I zoom in on this one here, for example, so this is an end here, and yes, you can see we've got two holes in here. We've got a slot in here. Now that slot is designed into it so that this piece here, the beginning of the steps and so forth, will actually slot into here. And then, for example, we've got these sections here, which there's a base section, and then there's these two dots here. Now these two dots, of course, map onto here, and of course they're not grouped, but if we drag that over there, you can see that the two dots fit into there, and those two dots are part of this piece here. So if we go back to our TinkerCAD, so I'll go and open up another file here, and what have we got? We can go to the gallery. Now these are all sort of different parts here. You can actually see my toilet that I did in the last episode. We'll go to this here. So these are lattice posts. So if I open this up, and what we can actually see here is these are our posts that are going on the inside of the footbridge structure. So if we flick back to Illustrator down here and move over, that's what this is. So there's our rectangle and there's our dots, and so that's what we're actually seeing here. So how do I do all of this? How do I get, for example, these items here, and then if we go to something like this here, which is our end pieces, and here's our end pieces, which are all set up and ready to go as well. So what we'll do is we'll go into, let's just do a new, start from scratch, start from new, and this is really the best way I sort of found of being able to do this, because I can design everything up in Illustrator, get it nice and accurate. So what we're actually looking at is, if we go to import and we'll choose a file, and what I've actually done in Illustrator, for example, so for example here, and I'm pretty sure you can do this within Inkscape as well, is you can export out these shapes as a SVG file. So what I've actually done is I've exported each of these pieces out, so not all in one SVG file. So that's an SVG file, this is an SVG file, that's an SVG file, and so on and so forth. So they're all, it's like they're layers that are split apart into separate SVG files. So we'll have a look at this one first, and what I do is take a note of the dimensions of this particular object. So as we can see, it's 24 millimeters high and it's 20.1 millimeters in width. So if we go back to TinkerCAD, and let's see if I can find this end lattice, here it is here. So this is just an SVG file of that particular item. If we go to import, and we can see a preview of it here, and it's actually showing the entire canvas. So what we want to do is select artwork, so it's now actually only highlighting that component, and then for some reason, I don't know what it is with an SVG, it doesn't actually give you the accurate dimensions. So, but we know, and of course the longer dimension, this is a little bit weird here, that should really be height and width, but I don't know why it says, yeah. But anyway, we know it's 24 millimeters high, so if we click that, and here's our 20.1 millimeters, and we'll go import. And it pops it in, and here's our shape. Now it's looking a bit weird, it's way too thick, so but essentially it's brought that shape in. Now the first thing I do, because it's got a curve in it, we can actually select the object, and a little pop-up comes up that gives you some information about this object. So what we've got here, the quality's on 8, so let's bump that, max that out to 24, and of course that gives us a smoother curve here. And I have tried adjusting the height, the dimensions in here, and it actually doesn't work very well. It's a little bit weird. So what I actually do is, when you hover over these nodes, the middle nodes, it actually gives you dimension. So we've got that right, that's 24 high, and it's 20.1, but the height's not right. Now within this footbridge, what I've done, and I've kind of replicated it because of the laser cutting I did. So in the laser cutting, I used 0.55 millimeter black card. So I thought I'm just going to run with that. So the depth of this lattice, or the thickness of this layer, I'm setting it to 0.55 millimeters, and click return, and we now have our height. So that's just the beginning shape. We've got our slot here, which is what that return piece, the piece that returns and then goes down the stairs, that slots in there. And then we've got our holes here, which are basically just location holes for the posts, the extension to the post, which will be on the inside. Now the reason why that post is not on the inside is because what I need is a flat surface to begin with from underneath. So looking from underneath, this represents our hotbed, and if I had a post protruding down here, then this whole piece here would need supports, and the printer software can add those supports, but I'm actually trying to do stuff without supports needing to be added. So we've got the shape in here. Now what we actually need is we need a frame to add to this. So if we go up to import, choose file, and in here we should have a frame, which is just the outside, and once again it's got the slot in it, so we want that, and we'll open that up, and it's going to be the same dimension, so it's 24 millimeters high, and I've selected the art instead of artboard, so it's just the shape itself, and it's just out a little bit, but that doesn't matter. And we'll import that, and it basically dumps it exactly in the same spot as where the other one is. And you know, we can move this around and you can see where it's sitting. So we'll just Control Z, move that back. Now this one here, because we've got the slot in here, we need that to continue on. So I don't want this pink block to be resting on the bed. I want this to actually be up from the bed. So there's a little arrow here, and that moves the height of this object up. You can go down, you can go up. Now what I actually want to do is, we know that this is 0.55, so I'm going to make this 0.01 of a millimeter difference. It's so that we can weld these shapes. So I'm actually going to set this at 0.54, and what it's actually doing, and if you can zoom in, you can see it's slightly overlapping, so it's bedding in to that object on the base, but it's still got the slot up through in there, if you can just see in there. So now we can set the height. Now because we've dropped this down by 0.01 of a mil, this is going to need to be 0.50. 0.6 so that it's higher, and now we've got this shape here. So the reason for this, and the reason why I haven't set this down at the bottom, is because I don't want the pink bit blocking these holes underneath. So we're still retaining our positioning holes for the posts that are going to come up on the underside of this. And the last bit is the posts that run down each side. So we go back to import, choose file, and now we're after the posts, which I think is this one. There they are. And we'll import that, go to art, and once again this should be 24 millimeters, and we'll go import, and now we've got our posts in here. Now we have to do the same process, because what I don't want it to do is to block those holes. You see how it's blocked the hole because it's sitting on the base. So what we're going to do is we now need to move this block up. Now I'm going to use the same process. So we know that that's 55 millimeters. We know that this from there to there, from the base of this to there, is 55 millimeters. So that well, 0.55 I should say, sorry, 0.55 for both of those, which together equals 1.1 millimeters for that height. So what I'm actually going to do with this, for the height of this, is we're going to move this up, but we're going to make it 1.09 millimeters. So it's now actually overlapping this bit in here just a smidgen. So the reason why I'm doing this just smidgen of overlap is it means that I'm confident that when I weld all of this together into one shape, that it will actually be recognized as one shape. It won't be, if there's a gap in here and it's welded, then the printer is going to think there's a gap in there, and I had to think what would happen. So that's the reason behind that. Now the total height for this is, once again, it's the same, because we've added an extra 0.01 of a mil. We're going to make this 0.56, and that gives us our height. And there we have our shape that's an end piece. So that's that component there. Now we looked at those posts earlier, so let's have a look at that. So what we need to do, and because I've created those posts and exported them out as what is called an STL file, .stl file, I can actually go and grab those posts, which I've done earlier, and I've got to find them in here. It does create a few files. So we found our post here, Footbridge post. So I've got Footbridge post 1 and 2. So 2 is the thicker one, so we can have a look at that. That's the thicker side, the 2/3, and this is the thinner side, the 1/3. Now what we want is the 2/3 side here. So we'll import that. Now we can import an STL file back into TinkerCad, and the difference here when you import an STL file is it actually keeps, it has the correct dimensions. We see 27.8 millimeters, so we can import that directly, and it's dumped it in the middle there, and that looks a bit funny, doesn't it? We don't want it there. So we'll move that out of the way, and one of the first things that we need to do is rotate this, of course, and we've got functions here, rotate, so that's going to rotate it that way. This is the rotate we want, that's down at the end here. Yep, so we're going to rotate that 90 degrees in it, and it actually snaps if you go in this line here. If you move outside of it, it will just actually do increments, but that's what we want it to do. We want it to snap into place, and then we're going to bring this over, and down here we've got snap to grid in this bottom right hand corner down here. Now I actually want to switch that off because I don't want it snapping to anything, so we're going to switch that off, and then we're going to come in here and we're going to join our post on the end of here. And this is the same process where we can actually see you know, there's a gap there. So what we want to do is we sort of want to, and you can use the arrow keys on your keyboard to nudge us into place. And I actually just nudge it a little bit further in than what it needs to be, so that it's actually got something to anchor to. And of course the other thing that we're actually going to do is make sure that it's centered. Now, I mean, there's not a science in this part, so we just want to make sure that this piece here is lined up with that column in there, and there we have it. So we've got a post attached. Move that out of the way. Now, there are some common sort of shortcuts within TinkerCad. So Command D or Control, might be Control or Alt D, will do a duplicate, and then we can drag it out and move it to there. So that's sort of basically how it's done. And then we can select the entire object, and then we go up to these functions here once again, and we go to Group. And what it will do is it kind of basically it welds it together, and of course we can choose a different color for it if we want. So we'll go for the gray, and there's our shape. So once you've done that, then we just simply go up to Export, and we're selecting .stl. So there's an SVG for laser cutting there, I didn't know that. Now I use STL. This seems to be Bambu Lab. There doesn't seem to be any issues with STL. Not sure about these other ones. So we export that out, and then it makes a file for it. Now, interesting, I've just noticed now we've got funky SVGs layer up here, which is just a silly name. Now, it's because TinkerCad just does these random weird names. So let's just go lattice end. We'll go lattice end. And just type that in there, because there's no sort of save function, there's no save button within TinkerCad. It just sort of seems to automatically save your projects as you go. So if we now go to export, choose STL again, and now it's going to actually save it. Now if I drag that out, and I'm just going to save that into my Footbridge folder, and then if we go to Bambu Lab, and of course this is going to be different for whatever printer you're using, obviously, but in Bambu Lab, if I go to create new project and go up to here to add an object, and there's our lattice end, open that, and there's our shape in Bambu Lab. And that's basically it. That's currently how I'm working this process. Now, in a way, it's kind of interesting because I'm using Illustrator and TinkerCAD in order to produce the shapes. You could produce this lattice work natively in TinkerCAD, but I think it would be actually really complex to actually do that, because there would be a lot of fiddling around to do this lattice work and all that kind of thing, finding the shapes that you need, doing this kind of stuff. And so I use Illustrator to basically design the shape and then bring that shape into TinkerCAD as an SVG and essentially extrude that shape to the depth or the thickness that I actually want it to be, which I know is basically it's basically Autodesk Fusion rolled into one. That's what Autodesk Fusion does. So that's like my Illustrator and TinkerCAD in one software package. But the reason why I sort of put a pause, or I wouldn't say I've given up on Autodesk Fusion, but I just don't like the way the initial 2D environment actually works. I'm just not familiar with it. You know, I would have expected it to be more like an Illustrator type kind of thing, and it's just completely foreign. And you know, I much prefer to work in Illustrator. I've used it for decades, and so using Illustrator to design up my shapes, export them out as SVGs, and we can see here, like, there's our main lattice section here, and of course it's made up of two layers. So there's the lattice layer, and then there's the framework layer, and then of course it's a case of exporting that out of TinkerCad at STL, import it into Bambu Lab, and essentially click the print button, and off it goes and just starts printing, and it works really well. I think it's a bit of a weird system for, I guess, in the way of using two software programs to generate the 3D objects, but it works for me, which I think is important rather than me trying to figure out the likes of Autodesk Fusion. So as you can see from the process I've used, I've developed the Footbridge as a series of components, and then of course it's a case of assembling those components very much like how you would assemble a bought kit that you would find at a model shop. So the specific design process that I used in Illustrator, which then extended through to TinkerCAD, meant that I could design in elements or ways to actually fix components together, or at least give them strength and provide some alignment to the objects or to the elements so that they lined up while they were being glued together. So there were various lugs and then tabs and slots that were included into the design as we saw, and then they of course corresponded to each other when it came to the assembly process, and it certainly made it a lot easier, and it's certainly definitely a step up from the laser cutting. Now that's not to say that I couldn't have designed those parts into a laser cut version, and I may look into that, but I kind of feel like now that I've done it in this 3D printed version, I kind of feel like I don't want to go back any longer. Now I remember saying that I really wanted to embrace both forms of technology so that we had these sort of hybrid models, but I think there's going to be a situation where it's going to be best to do something entirely in 3D. There's going to be other situations where it will be best done entirely laser cut, and then of course there will be hybrid scenarios. So I think one route that I'm not really planning on going down is building it's designing an entire building that's 3D printed. I still like the laser cut and brick texture approach. It's something that sort of sits with me really well, but in terms of things like footbridges, lamp posts, guttering and downpipes and window frames, that kind of thing, that's where this 3D printing is really going to make its mark in terms of the scratch built models that I make. So there we have it for our first fully 3D printed footbridge, and I'm pretty happy with the way it's come out. There's definitely going to be other areas that I'm going to change and improve on when it comes to doing Law and Gill's footbridge as well. So some of the components that I didn't really sort of think out at the time when I was designing it was the intricate sort of arches on the inside corners of the two end pieces, the landing areas at the top of the stairs. If I'd incorporated them in prior to actually putting in the other half of the posts, that would have given me a better guide, because I kind of feel like some of the when the posts are joined together, they're not overly accurate, so that you can see the seam a little bit. But I think if I had those intricate arch components in there, then that would give me something for the other half of those posts to actually line up to. So there's all sorts of little things that I sort of, as you build these things, you sort of think, oh well, yeah, I should have done it that way. But all in all, I'm actually pretty happy with it, and as far as the footbridge on my layout is concerned, I'm happy to run with this, and it certainly looks the part. I've got a prototype 1 footbridge there, the hybrid, the laser cut version. I may find a use for that elsewhere. Now, speaking of the footbridge on the platform, and of course we can now actually see our platform 2 building, and then of course we've got our gents toilets. Now this brings me to an interesting topic, of course, about the 3D printed toilets that I did in the previous episode, and I must admit I did get an awful lot of comments about the toilet seats shouldn't have been white, and they should have been black or sort of a timber finish, and there shouldn't have been a toilet lid, should have just been a seat, and all of those kind of things. And you're absolutely right for all of those who did comment on it. When the station in question, the old station, was built back in the late 1800s, of course there's highly unlikely that there would have been white toilet seats, and there probably wouldn't have been a toilet lid. Now, the interesting thing is, of course, these toilets are for my layout, so this initial run of the Station 2 building, the gents toilet station, the main station building, the footbridge, the whole thing is based on my layout. And of course my layout is based from the late 1950s through to the early 70s, so it's over a decade of coverage. And also my station is current, it's still in operation, so to a degree it's a certain amount of it is looked after. It's not been left into rotten decay and so forth. So I'm going on the basis that maybe in the late 50s, sometime in the 60s at least, the toilet seats were replaced, and also a toilet lid was included as well, because I did do some research to find that white toilet seats did come in, I think, as early as the 1930s, and it was to do with hygiene. So dark or wooden toilet seats or black toilet seats, of course, didn't show up, you know, the stains that you might find, and so white toilet seats came into being really to sort of highlight any hygiene issues. So I'm going on that basis. So for at least for my toilets on the Station Road layout, they were modernised maybe in the 60s, that the white toilet seats and the lids came into being. So I think for Law and Gill's model, which I'm not going to base their model for right at the beginning, like when the station first opened, but it is going to be based on while the station was still in operation. And I think it would be pretty obvious that the seats probably wouldn't have been upgraded in any way. They'd still be the original seats. Now I have no idea what they would have been. Chances are they might have been, I think, probably wooden toilet seats, and there may not have been a lid. So of course for Law and Gill's gents toilets, they will be true to that particular era. So there we have it for the fully 3D printed footbridge. Of course, the next stages to get onto is actually painting this all up. Now, I'll probably do this off camera, so it's going to need a primer, and then of course it's going to be a case of going through picking out colours, much like I said I was going to do with the hybrid footbridge, the laser cut combination 3D printed bridge, which only actually got to a primer finish stage. I hadn't got round to painting that up fully. So I'll leave it there for today's episode. I certainly hope you gained some inspiration and ideas for your own layouts, and if you're considering delving into the 3D world of model making, maybe hopefully I've given you a little bit of insight into TinkerCad, into how you could use that, which is very basic 3D modeling software, to produce actually reasonably convincing miniatures. So do take care, everyone. Look after yourselves. Of course, don't forget to like and subscribe, and I will catch you next time. Bye for now.